CSEC Mathematics, May 2025. We are at question 6. It says PMQROS. PMQROS. That's the entire shape here. Is the cross section of a play area in a park. PQRS is a rectangle, all right, and PMQ is a semicircle. Okay. O is the midpoint of RS. O right here. The midpoint of RS, all right? OP equal OQ equal 15 meters. And angle POQ equals 40 degrees. All right, we can see it here. Use pi equals 22/7. Determine the value of the angle OPQ. All right, so I think we have all the values here already. Let's just copy this thing and paste it over here. All right. So here we have it. What is it now? Determine the value of the angle OPQ. Let's just see if we can get this and put it over here. OPQ. Now, OPQ would be this angle right here, OPQ. All right? Now, the thing is, when we look at this triangle, you can see if O is the center here, the length OP and OQ is 15, both the same, 15. In fact, they told you that too. Did they? Yeah, OP equal OQ equal 15, right? So that means OPQ is an isosceles triangle. It means that this angle OPQ is equal to this angle OQP. So OPQ equal OQP equal, let's call it X. So X plus X, that would be this plus this, plus 40 equals, so you remember now, the total internal angles in a triangle is 180 degrees. 180. See that? So x plus x is 2x plus 40 equals 180. Subtract 40 from both sides. So 2x plus 40 equals 180. But you minus 40 on the left and minus 40 on the right. So 2x. This is gone. That's subtract itself. 40 minus itself equals 40 minus 180. 180 minus 40 is what? 140. Alright. So 2x equals 140, and you divide both sides by 2 to get the x alone. 2 cancels itself. So you have x is equal to 140 over 2 is 70 degrees. So you have 70 degrees for that. Alright. And let's calculate the length of OR. Let's copy this thing and paste it over here. Okay. The length of OR. Now OR is this. So let's see what is going on here. Now we already found out that this angle is 70. You see OR, it's in this triangle here, right? It's in triangle ORQ. Now, here, this is 90 degrees, right? Remember what they say. PQRS is a rectangle. So it has 4 90-degree corners here. So that's 90 degrees. Now, if we can know what the angle up here is, which we know, 70. The total angle here is 90 degrees because it's a rectangle, so the remaining angle is 20 degrees. Alright? Now here we have RQ is 14.1 meters. See that? So we can find our OR. Now looking at this, we have this angle at the top of the triangle, the side OR at the bottom, so they are on opposite side. We have the adjacent side to the 20. You see that? No. Oh, this is 15. I forgot this is 15. I was thinking of using the trig ratios to do it, but we have a 15 here. We have more than one ways to do it. I was thinking of saying tan 20 is OR over adjacent and then using that. But we could use Pythagoras, 15 and 14.1. Alright. Let's use Pythagoras. We would say what Pythagoras theorem says is that the hypotenuse square root is 15 squared, which is one of the other side square, or squared plus the next side square, 14.1 squared. If you transpose, you get OR squared is equal to 15 squared minus 14.1 squared equal. Let's reach for our calculator and see how that will go. 15 squared. Oh, it's not plus, it's minus. Minus 14.1 squared equal 26.19. And then the square root of 26.19 is 5.1. Alright. So 5.1. So it was 26.19. And then OR, square root of OR squared is OR. And the square root of 26.19 is 5.1 meters. Alright. Remember I said before I was planning to use trig tangent. Let's see how that would work. Tan 20 is opposite OR over adjacent 14.1. So OR is equal to 14.1 tan 20, which is, if we use our calculator to do that, make sure it's alright. I have to put it back in advanced mode here, degrees. So just to make sure that it's really in degrees, if I find sine 30, I should get 0.5, right? So tan 20 is that multiplied by 14.1, right? And I get that the 5.1, right? You have used any method you want, but anyway, that is that 5.1. It is. So we got the length of OR 5.1. The area of the shaded portion of the diagram. All right. Area of the shaded portion of the diagram. Now, remember what they say here? Semicircular. All right. So the top part, the curved part, is semicircle. So what we're going to do, you see, to get the area of the shaded portion. And by the way, let me copy and paste that part. And pull it somewhere where there is space to work with. All right. The area of the shaded portion. Let's just copy this diagram and pull it down. We're going to use it again. Now, the thing is, to get that area, we have a triangle here. Let me try and draw back that line again. All right. So we have this triangle. All right. Let's concentrate on that part. The triangle. And find the area of it. Later on, we're going to deal with the semicircular part. The triangle. This triangle, it could have been drawn like this too, you know, just spin it around. But the basic idea here, the area of a triangle is half base times the height, the vertical height. The base is what? Now, we found OR to be 5.1. From O to R is 5.1. So from S to R, SR is 2 times OR, which is 2 times 5.1, which is 10.2 meters. Right? That is 10.2 meters. So this part here is 10.2 meters. And the height is 14.1. So what we have is half times the base of 10.2 times the height of 14.1. Half of 10.2 brings us back to 5.1. 5.1 by 14.1 will give us the area of a triangle. I'll just call it A and this. You must write out the word though, you know, don't bother to draw the triangle there in exam. 5.1 by 14.1 is what? Let's take this time. 14.1 equal 72.36. 72.36 meters squared. Okay, good. The semicircular part, let me just call it this. Well, you could, in exam, you know, you could say A1 is equal to area of a triangle, and then you, right? Or not the area of a triangle, area of triangle PQO, and then work it out. Or you could say AT, or A PQO, subscript PQO, whatever you want to name it, but specify two different areas. right? You could call it AT equal, and then you write down that it is the area of triangle PQ, and then you calculate it. And then write AS equal area of the semicircle PMQ, and then you work it out. Right? Whatever you want to call it. But anyway, A of this is going to be the area of a circle is half. No, the area of a circle, is pi times r squared. But it's a semicircle, so it's going to be half. Semi means half, right? Half pi r squared is going to be half times, is here, let's say use pi as 22 over 7. They say that, right? Okay, good. Half times 22 over 7 times r squared. What is the radius of this semicircle? It's 10.5. You can see. You have the 5.1. You have the 10.2 going across, so it's 5.1 halfway there. So half pi r squared, so it's 5.1 squared. Alright, so let's get our calculator and work it out. So what we have is 0.5 times pi times, oh, it said use 22 over 7 times 22 over 7 equal, alright, times 5.1, where's the square? They don't have a square. Oh, when it's in this calculator is in advanced mode, they don't have a square. They replace it with to the power of. Alright, 5.1. You could say times 5.1. 5.1 square is the same as 5.1 by 5.1. What do you get? 40.87 equals 40.87. Alright? Now, the area, I just call it A shade. You could say AS and say this is the area, the total area of the shaded region, the shaded portion. AS is equal to the area of the triangle 72.36 plus the area of the semicircle 40.87 equal 72.36 plus 40.87. We could use a calculator, but it's good. Sometimes it's good to practice this way, although you wouldn't have time to do that in exam. But anyway, 7 and 6 is what? 13, bring down the 3, carry 1. 8, 9, 10, 11, 12. 12, bring down the 2, carry 1. 2 and 1, 3. 7, 8, 9, 10, 11. 113.23. Alright, so what we have is 72.36 plus that. Alright, so that's what we get. Alright. So 113.23 is what we got for, or just about 113, if you want to call it that. 113 meter square. When you find any value, you must write down the units. The unit in this case is meter square. Alright, so what else do they say? The shaded portion, the perimeter. Alright, for 3 marks. The perimeter. Remember the word peri. What did they say? It's Greek. or Latin. I think it's Greek, you know. One of them, Greek or Latin. Let me look it up. The word peri. You have perimeter, right? Peri means around. Peri means around. Greek, right? The Greek prefix peri. It means around. Meter means to measure. So perimeter, it means measure around. Alright? So find the perimeter of the cross section. Let me just put the perimeter to one side. Perimeter of the cross section, PMQRS, since we have it close enough. How could do, you know? Is just copy the diagram and label it. Let's use up the space down here. Alright. Let me just make a copy of this thing and put it down here. Alright, good. Now, what are the measurements we have? We have 15 meters here. 15 meters. I didn't bother to write the M because I don't want to crowd the diagram too much. Oh, hold on. What is it? The perimeter of P. Hold on there. Okay. PMQRS. Oh, it's the whole thing. It's the whole thing I want, man. Or run out of scrolling space, you know. Can't scroll down anymore. But anyway, alright, these 15s would be necessary. Alright, so what we have? 14.1 down here. Okay. We have 14.1 here. What was it across here again? 10.2. 10.2 across here. Alright. So the only part we don't have so far is the length around the perimeter. Alright. Now, if it was a whole circle, then the perimeter of the circle, which we call the circumference, would be 2 pi r. But now, this is the thing there, the semicircle. The perimeter of the semicircle is half 2 pi r. Half and by 2 is 1, so it's just pi r, which is what? 22 over 7 times. The radius was, I think, 5.1, right? 5.1. Pi times 5.1. 22 over 7 by 5.1. So that's 22 over 7 equal times 5.1 equal 16.029. 16.029. Alright. So that means that this is 16.029. Going around. Whoa, so that's what we have. Now the thing is, the perimeter that they asked us for, call it P equal. Starting from here, we go down 14.1. That's 14.1 plus. Then we go across 10.2. That's 10.2 meter plus. Then we go back up 14.1 again. 14.1 plus. And then we go around 16.029. So we have 16.029. Alright? Now, what does that give us? Okay, we have the 16.029 already. Plus 14.1 plus 10.2 plus 14.1 equal 54.4. So we have 54.4 meters. All right, that is the perimeter. All right. And that is it for question 6. Remember to like the video and to share it with somebody else. Any comments, any questions, and so on, you put it in the comment section. All right. And if you're not a subscriber, make sure you subscribe to this channel. That's part of your homework. All right. So I'll see you next time when we do the next question.